process. The application of metal to glass to create mirrors began in the late 12th century, a process that was refined in Germany in the early 1800s to incorporate a silver-backed mirror. The use of silver to create mirrors has evolved into the automatic silvering process found in modern mirror factories today. The silvering process, by definition, is a chemical wet deposition of a silver solution into a plating process on flat glass. There are a variety of subsequent coating processes for stability and protection, which is typically dictated by the end use of the mirror product. The creation of mirror begins with a single sheet of glass called a light. The light is placed onto the line and run through an intensive wash process using deionized water, cerium oxide, or other materials to remove any contaminants and oils that may be present on the glass. This cleansing can take up to a minute per light and prepares it for the process of plating metals onto glass. The deionized water rinses the glass at an average of 40 psi, and water temperatures are adjusted to achieve a glass temperature between 80 and 90 degrees Fahrenheit, which is optimal for the tinning section of the process. In the tinning process, the silver solution is sprayed onto the back surface of the glass. Since silver will not adhere directly to glass, this ultra-thin layer of tin will stick to the glass and provide a material for the silver to adhere. After the tinning process, the light is rinsed once again with deionized water, and the temperature is elevated to between 90 and 100 degrees Fahrenheit, preparing the light for the silvering process. Silver is what gives mirrors their reflective quality. In the silvering process, a silver solution is applied to the light. When the silver solution is mixed with an activator, pure metallic silver plates out onto the surface of the glass in a uniform coating of a thickness between 70 and 80 milligrams per square foot. After application, the light is passed under a high-velocity air knife to remove excess water before entering the copper section of the process. As anyone who owns silverware knows, silver oxidizes or tarnishes readily. To protect the silver layer from oxidation, one of two methods can be used. One is a process called passivation, which treats the top of the silver film and reduces the risk of oxidation. The other is the application of a layer of metallic copper on top of the silver, as shown here. A copper sulfate solution is applied to the light simultaneously with a slurry of iron powder, causing pure metallic copper to plate out onto the silver surface at a thickness of 15 to 18 milligrams per square foot. This protects the silver layer from corrosion, much in the same way an iron pipe would be galvanized with zinc. The glass is rinsed once again, dried using pressurized and heated air and ovens, and proceeds to the painting section. The paint backing of mirror is applied for protection of the thin reflective coating. Manufacturers of mirror can apply the protective paint backing using a roller coater or a curtain coater, named so because of the curtain of paint raining down in a single and continuous stream, applying a uniform coat of paint to the back of the mirror. This can either be done in a single, thick coat or in a dual coat process, whereby mirror is run first through a curtain coater or roll coater, which applies a single, thinner layer, and then through a final coater, which features a different colored paint to differentiate between the two coats. An ultraviolet top coat is an alternative to a second layer of paint. After the application of the protective layer, the mirror is moved into the final oven section. The mirror cures in the ovens as it continues down the line. Heated to a temperature of between 265 and 285 degrees Fahrenheit, the mirror takes approximately 6 minutes to move through the ovens and be properly cured. Once out of the ovens, the mirror back is labeled automatically by date and time of manufacture. After a final short curing process for the labeling and another cleaning process, the mirror arrives at the end of the line where it is removed for further processing. Mirrors may go through a variety of post-manufacturing processes. Mirrors can be cut to pre-specified sizes, including specialty sizes. This cutting may be done by automatic cutters or by hand. Mirrors may be beveled, Mirrors may be polished. Finally, the mirrors are packed up and shipped off to their final destination, which may be a furniture manufacturer, a